Hey everyone, today we're gonna be doing a Leetcode question which is to find time needed to buy tickets. Okay, so we are given some n people standing in a queue or a line where the 0th person standing in a queue represent the front of a queue. Similarly, they are saying that 0th index array, you can say that integer array tickets represent the person standing it. So there, if you say this 3 element in the queue means 3 persons are standing in a queue and their ticket, you can say they are saying okay, this ticket array represent that ith person required how many tickets, like how many tickets they want to buy in that ith index. Okay, they are saying each person can take exactly 1 second to buy one ticket. It means if a person buy one ticket, it will take 1 second to buy this. Similarly, they are saying okay, person can buy one ticket at a time. So there is like if the person required two tickets, they need to buy one ticket and need to go to the last of a queue. So they are just saying like if a person buy one ticket and if they want more ticket, they need to go back to the end of a line. So no two person can buy more than one ticket at a time. They are also saying a person does not require any ticket or just they have completed buying their own ask of a ticket. If the count becomes zero, you can say they don't want like they don't want any ticket further. They need to remove from the queue, like just they need to go out from the queue or this person will leave the line. So we are required to ask like what is the total time taken to buy all the tickets for a particular person or a particular index. So if you see this is some ticket array given means there are three person in this array. You need to tell the second index person, this person, how much time will it take for this person to buy its two tickets. So first person, okay, well let's see like how to do. Let's see all the constraint over this. So they are saying okay, n is the size of a ticket, like total size of a array, and they are saying that size of a array can go from minimum 1 to 100. Similarly, the ticket inside it, like the person asks, you can say how many ticket a person want, can go also from 1 to 100. And same like that index, like which particular person we are asking to get the time for it. So they can go from 0 index to n index. Okay, less than n you can say. So you can say, okay, let's understand with some example how to do this question. So if I take the first example itself, so we are given some ticket array, tickets array. So tickets array like having three person in it, which is representing a person required three ticket or two ticket or like two ticket, three ticket and two ticket. This is person. Okay, this person P1, P2 and P3 represent like how many tickets they want. And what we are given some integer k. K means the second index. In this example, with second index, they are saying how much time will it take for this person. So how much time will it take for this person to buy complete its ticket? What I'll do, okay, what we can do, I'll say just one person I'll say, okay, take one ticket and stand at the last. Take one ticket, stand at last because they are saying one person can buy one ticket at a time. If they buy one ticket, they need to go back to the line. If this person buy one ticket, they need to go back to the line if they want a ticket further. If we take one ticket, it will take 1 second. So they are saying for this particular person, how much time will it take to complete its ticket? So what we can say, okay, let's say this was an queue. We'll say, okay, we have some queue. I'll say this was my initial queue. I have some queue, which is a line. You can say line or queue. What I'll say, okay, I have some person. I'll say I have initially my person 1, person 2, person 3 standing in this queue with some ask of 3, 2, 3 and 2. This means this person required this many tickets. So one person can come and say, okay, I want one ticket. I'll take one ticket and I'll sit at the last of a queue. I'll say, okay, I buy one ticket. I'll go to the next like, end of a line. Okay, person one will stand here now. Similarly, person two will get one chance. He will say, okay, I got one chance. I'll also say, I taken one ticket and I'll stand at the last. Similarly, person 3 will say, okay, I'll buy one ticket, I'll go to the last. And what we need to see, we need to find the kth person, the second index person. You can say 0, 1 and 2. this is some index 0, 1 and 2. We need to say, okay, second index person or the third person. We need to say how much time will it take for this particular person to buy its asked, you can say, this required tickets. So if I say, okay, this person now have taken the tickets, now again this person will get chance because these three person have taken their chance. Now the row will like go on and on and on and on. So now the chance will come for again first person. He will buy one ticket. He will say, okay, I have buy one ticket. My ask is 0 now, so I cannot include this in my array because he no longer wants some ticket. Similarly, now my chance will get to this person. He will say, okay, I need one more ticket, I'll stand in this queue. Again this person will get chance. He will say, okay, I don't want some ticket, this is person 3. He will also not stand in the queue. So if you see each time, if I say each time this person like at the T1, T2, T3, T4, T5 and T6, you can say each time we have taken, or you can say a person have taken one ticket and just keep on he is like taking one ticket and going to the last of a queue. He have taken one ticket and gone to the last of a queue. He has taken one ticket and gone to the last of a queue. If person required ticket, he will stand, otherwise he will not come to the queue. But he will take time to buy this ticket or go out from the queue. So if I say we are checking for kth index person, we need to see keep track of this kth person. Kth person means third person. Okay. Here 2 is second index means third person. We need to find when will this person will buy all its tickets. So I'll say okay at t time he has bought all its ticket. So what we have done, like we have initially created a queue, like we have what we have done, we have like created our queue. Okay, queue means this is some front of a queue and this was a rear of a queue. So we'll take one element from the queue and we'll append at the rear of a queue. Front will pop and here if I say front I'll pop and rear I'll push. So if I say this queue works in a FIFO order, first in first out. So it will come from here, append here, come here, append here, come here, append here, come here, append here. So what we need to do, we need to keep track of all of them. So what we have done, like we have iterated over the array the end time as well as like how many time this person repeat, like we are checking of this index. So you can say we have iterated n into m time, or you can say n into k times. This was our time complexity and we have stored the this you can say person in the queue. So we have taken space complexity as well as a n. So we have stored the n person in a queue and we have iterated over this n person k time to find the track of it. So we are required in a like question how much time will it take. So I told okay this will take 6 time. If you see for one I'll say okay. So what we say I'll just guide to the same question. So we have done this one, they have say, taken 6 time. If I say this example, what will happen, like they're just keeping out the first element track. So what I'll do, I'll note down this example as well. So our next example is uh, our example now is 5 1 1 1 and 1. Okay, so each time and we need to find k is given 0. This is our tickets and k is given 0. So we need to find when will this ticket 0th person, this person will buy its complete ticket. So each time if you see what we are doing, like we are iterating over the, if you see how can we optimize. So what I can say, okay, instead of like storing the elements to the queue each time, we'll say okay when this element, you can say this particular element or this particular element size becomes 0, I'll stop my iteration. If you see here, if this person becomes 0, I have stopped my iteration. So what I can do, instead of like creating a queue, I can iterate over this array. How much time? K times. So each k times I'll iterate over this array. So if you see what I am doing, I'm just taking one element. I'll say, okay, buy one element, reduce your count. Buy one element, reduce your count. Buy one ticket, reduce your count. Buy one ticket, reduce your count. So each time I have buyed one here, again here. This is our time. So at T1, if you see, this is our T1. I'll say, okay, T1, T2, T3, T4, and T5. Okay. At T5, we have buy a single ticket for all of them. But if you see, these 4% do not want ticket further. Their asks are over now. But we are now left with this first person asked 4 times. We are just keeping track of this person. We are given this is a person 0, or you can say person 1, or the k equals to 0. We need to find when will this person buy its all of the tickets. What I can do, okay, I'll say when this person becomes 0, the ask of this person will become 0. I'll stop my loop. So what I will be doing something, I'll say, okay, I will be iterating, or you can say I'll use some while loop where k is not equals to 0. This is my base loop. I'll say, okay, iterate over this array. Each time I'll come to this one by one, one, because if you see what we are doing, I am just taking one element and pushing it to the last. I'm just reducing one and pushing to the last. I'm pushing, reducing one and pushing to the last, reducing one, pushing to the last, reducing one, pushing to the last. Again, I'm starting from the same and I'm doing the same. Same means I'm just iterating over this array. How much time? K times. So if you see, I'll just come to this one, this one, this one, this one, this one, and I'll reduce its size. How much time? K times. So each time, like I have reduces this size by 1 means at time T5, this becomes 0 and this is 4. So at time I can say, okay, this will take another how much time? 4 time. So if you see at time, you can say I have taken one time here, 2, 3, 4, and 5. Again, if I have left 4 tickets, this person buy 4 tickets, it will take another 4 seconds. So I'll say, okay, if this particular takes 5 seconds, this will take 4 seconds. Total will be 9 seconds. What I say, like I have taken one extra one here. So if I remove this one, if I wrote exactly with the example, so if I say this person have buy 4 ticket, you can say this buy one ticket at T4. This is our 4 second for now. Now this person alone will take 4 second. You can say one, it will buy one ticket and it will become 3, again 2, then 1, then 0. So at T4 again, it will take 4 times. So I'll say, okay, total it will be 8 seconds. So this time, like we are just iterating over the array. How much time? N into k times. Okay, this is our time complexity, and space we didn't use. Space is constant now. Why k into n? Because what we are doing, we'll say, okay, while kth index for particular index, as you can say the element at that kth index, I'll say, okay, this ticket at kth index is not equals to 0. This particular person is not equals to 0. I'll just keep on iterating over this again and again. And each time I'll say, okay, iterate I over the 0 to n. Okay, I'm just saying iterate my I from 0 to n, because I just need to reduce its count one by one. So what I'll do, I'll remove, I'll just reduce its count, like ticket of I'll say minus minus, and time I'll say plus plus. If this is if I have my ticket I greater than 0. If it is not, like if it is less than 0, if ticket is less than 0, I'll just ignore this one. Okay. If I say this particular 3 case does not require any ticket, I'll ignore this part. So for this one alone, it will keep on incrementing my time and it will decrement its ask. So this time, like I have done in like time complexity, I like space I have reduced. Like initially what I'm doing, I have created a queue. So for that I have taken n into k as a space time, and n I have taken the space. For this example where we are just iterating over this array again and again, this time I have taken n into k as a time, but space I have optimized. Now how much I can optimize further? So if you see, like what we are doing, we are iterating this again and again, or I was storing this to a queue. So what I can do, I can extend this iteration. What I can do, I can just extend my iteration, and each time I'll say, okay, each time what you do, I need to do in a single pass. So I'll say okay, iterate over this array again and again. If you see here, if you look at here, I'll say mark this first example 2, 3 and 2. Okay, this is our tickets array and they are given sum k equals to 2. Okay, for this person, I'll say for this person, let me know the time required. Time required. Okay, so what I'm doing, just I'm taking one ticket, going to the last, taking one ticket, going to the last, taking one ticket, going to the last, one by one, one by one, one by one. So if you see each time, like if something is coming in the go, if you see, if it is going again and again and again, what I can do, I can take all of the tickets. I'll say, okay, I will take two times. I'll say, okay, I will take three times to buy all ticket. He will say, I will buy two tickets. If you see, this person say, I'll take two times. You can say 2 seconds to all to buy all of the tickets. He will say, I'll take 3 seconds to buy all of my tickets. He will say, I will take 2 seconds to buy all of my tickets. So what I need to say, I just need to buy how much ticket? If this person takes 2 seconds or this person required two tickets, so the person coming before this should also buy two tickets at a time. If you see here, what we are doing, this person required one ticket. We are just taking one, again taking one, taking one, taking one. So we are taking one, you can say ticket at a time. Similarly, we are doing the same. So if you see in this example here, what we are doing, we are just reducing its size. You can say 2, 3, 2. Again, if you see, we have taken one and reduce its size. Like for this person, I told just buy one ticket, go to the last. Or you can say I'm just doing this approach, this one. Buying one ticket, going to the last, buying one ticket, or just I'm iterating over this array. So I'll say, okay, this person buy one ticket, reduce its size. This person buy one ticket, reduce its size. This person buy one ticket, reduce its size. Okay, so this time its size become this. Again, it'll say, okay, this person buy one ticket, reduce your size. Person buy this ticket, reduce your size. Person buy your ticket, reduce your size. So if you see, we are just iterating and doing the same. Like I'm reducing one from here, one from here, one from here. So I just need to say, okay, person coming before with this person can buy exactly this many. You can say person coming before this person. Any person coming before my kth position person can buy exactly, or you can say at most k tickets. Or you can say kth person, like if this person is buying two tickets, any person coming before this particular position can buy at max how many? This many, two tickets. If you see this example, I'll say person coming before two this second position, or say person P1, P2 and P3. Person coming before P3 can buy at exact, you can say you can say what, exactly two tickets, like not exactly, at most I can say. So person coming before 3 can buy at most two tickets. How many tickets? 1 and 2, 1 and 2, 1 and 2, because it will keep on repeating, 1 they will buy, then again 1 they will buy, means they can buy two tickets at a single time. How much, like minimum of this, like this person can buy two tickets, so any person coming this before this can also buy at least two. If this person can buy two tickets, the person coming before can also buy two tickets, or you can say if they are buying one ticket, they will get one more chance to buy one ticket. So at last they will say, okay, I can buy two ticket, I can buy two ticket at a time. Like at max, you can say at how much time? At max two time I can take for this one. But if you see, if I say for this example, okay, I'll change the example. I'll say, okay, two here, three here. Now I'll say this is my person. I am just keeping track of it. And this is my person. You can say K is one here. Now I'm saying person coming before can buy exactly K ticket, but person coming after this position can buy one ticket less than this, because if you say, if they are buying the exactly K time, it just need to buy one more ticket. If he will buy two tickets, it means he have buy how many tickets? One, because if you see, one person will one here, if you see, one will come, buy one ticket, this will come, buy one ticket, this will come, buy one ticket. Again, this will come, buy one ticket, this will come and buy one ticket, this will come and buy one ticket. So each time they are buying and reducing its size. So how many times you can say minimum, like at exactly you can say at max you can go till how much this index value you can go. Okay, but if you say person coming next to it can buy one ticket less because this person getting chance before this one. If this person stopped at particular position, if you say I have stopped at this position, my just the count of this will be 2. If I say I'm just iterating over this array, I'm just checking if this person count is 0, I just need to stop. I'll just keep reducing my count one by one. Initially it was 2, 2 and 3. I'll say okay, buy one ticket, reduce your count, buy one ticket, reduce your count, buy one ticket, reduce your count. I'll say I'm just keeping track of this person. Okay, I'm just keeping track of this person. So if this person becomes 0, if this becomes 0, if this person become, if this becomes 0, I need to you can say stop. Okay, I'll stop. So what I'll do, okay, I have reduces in my one pass. Second pass, what I'll do, I'll again reduce it to 0. It will get reduced to 0. If you see here, this get reduced to 0, this loop will get break. So it will not get one chance to reduce its size. So this like person coming after the kth person will reduce one less. You can say this person will get reduced one less than this because it will, if it is not 0, then he will get the chance to reduce. Otherwise, if this becomes 0, it will not get reduced. So similarly, we'll follow this approach. I'll do some code, let you know how to do this one. So let me write this code, and by seeing the code, you will get easily like what I'm trying to say. So I'll say I'll start my time from 0. I'll say okay, I'll iterate. I'll say okay, for I in range, how much time? I have some size, you can say. My n is given length of tickets. Okay, so this is my tickets, and I'm like iterating till n. What I'm saying, if the ith position index is less than equals to kth position, it means the value inside, I can say, we are just standing at some position which is less than the kth position. And like person coming before the kth index or equals to kth index can follow my previous like minimum of, you can say, which the person you need to buy some ticket for a specific person. I'll say this is my specific person ticket at kth index. So all the person can buy at least, you can say minimum, you can say this person how much can buy. If the person is buying k ticket, if you see here what I'm trying to say, I'm saying person coming before this one, here if you say, I'm saying person coming before this one or person coming before this one can buy exact, you can say at least, or you can say at max, sorry, at max. So person coming before to this position can buy at max k, you can say k ticket. So what I'm saying, okay, person coming before this can buy 2. Okay, is it 2? This is 3, but he can buy 2. So I'll take minimum of them. Similarly, I'll follow the order for the next case. So what I'll do, okay, minimum of ticket at the ith index. So I'll say tickets at ith index. So person can buy either the minimum of both of them. So I'll take the count as a plus plus, or you can say time will get increased kth time. If this is not the case, like the person coming after the you can say kth index, what I need to do, I need to do time plus equals to, I'll take minimum of both, but this time I'll take one less. If you say what I have explained, like I'll just iterate over this array. I'll say okay, you can buy one less than the kth person, because if this becomes 0 at one time, you cannot reduce your size. So I can say minimum of this one will get reduced from your size and it will be counted as a time. So at last I'll say okay, return my time. So if I run this code, let me see if it is working fine or not. So this time, this throw the error. Oh, okay, time is initialized to 0, not minus. So I'll compile my code again, and If you see this got accepted, I'll submit my code, and this this might work. So yeah, this worked, and we have done this in a linear time. You can say in order of n we have done without taking any extra spaces. So that was all for today's. Thanks for watching.